Hello teachers, my name is Asfar Nasir Adrian. Today I'll be presenting my Emaths 3 assignment on Euler's method and my admin number is 2501183D. So today I'll be demonstrating how to use Euler's method to approximate the solution of the initial value problem which is given over here. So before solving the question, I'll briefly explain how Euler's method works. So if you could take a look at my graph that I have drawn over here, my diagram. So the curved line in this diagram represents the exact solution of the differential equation. However, in most cases, we don't know this exact curve. So Euler's method estimates it using tangent lines, which is here. So we begin from the known initial point, which is in this question 0, 1. At this point, the differential equation gives us the gradient or slope of the tangent line, which is this line over here, this long straight line here. And instead of following the unknown curve, Euler's method assumes that the tangent line is a good approximation over a small distance. So now I'm going to derive the Euler's formula itself. So we know that slope is equal to the change in y divided by the change in x. And so since the slope is given by the differential equation dy over dx equals to the function of x and y, we can approximate that the change in y over the change in x is equals to the function that equals to the function of x and y. So since the step size is h, we let h to be the change in x. As you can see over here, I wrote sub x equals to h, and therefore I can derive Euler's formula where yn plus 1 is equals to yn plus the step size times the function of x and y. So I used two different step sizes, as you can see over here, h0.1 and h0.5. The first column contains the x values, the second column contains the corresponding approximate y values, and the third column calculates the gradient using the differential equation as given over here. So for the first iteration, the initial condition is 0, 1, and the gradient is 2. As you can see, my Excel formula here. And then using Euler's formula, I get to approximate the next value of y by using this Excel formula. And over here is just simply the initial x plus 0.1. This is the next approximate value of y using the values. So by using the step size of 0.y, the approximation obtained all the way is 2.40263. While when I used 0.5, the step size, the Euler's approximation is 2.5625. So you can see these are all my Excel formulas. Want to take a look and double check, make sure everything is correct. And then now, to evaluate the accuracy of Euler's method, I solved the equation analytically, which is shown by my working over here, where I integrate both sides, I bring over the y, etc. And I found that the general solution is 2.380476. Okay, and then now I'm going to compare that with my step sizes where h is 0.1 and h 0.5. It is shown that the percentage error for the h is 0.1 is negative 0.93072, while the percentage error for the 0.5 step size is negative 7.64654. So this is evidence to show that using a smaller step size produces a more approximate and accurate approximation because the tangent lines follow the actual solution curve more closely. As you can see, I have proved this here by using a different value in the step sizes. That is all for today. Thank you for watching my video.